Right now, the largest technology companies on Earth are engaged in a $100 billion spending spree. They are buying every high-end chip they can find to build a future they believe inevitable. The logic behind this investment is a brute force thesis. To make AI more capable, you must exponentially increase the hardware and the energy used to train it. Scaling has become the industry's primary law of physics. NVIDIA's Jensen Huang structures this ecosystem into 5 stacked layers. It starts with energy, which powers the chips, which are networked into infrastructure, which hosts the AI models, which finally run the applications we use. Because the models at layer 4 are becoming more complex, the market assumes every layer beneath them must scale at that same expensive rate. This creates a cycle where better AI requires a permanent, growing commitment to hardware spending. This assumption is what sustains the current AI equity rally. If these hardware costs are mandatory to stay competitive, the investments are rational. But if smarter architecture can bypass those costs, the financial math supporting these valuations will have to be recalculated. A Chinese lab called DeepSeek recently tested that math. They released a model matching frontier-level performance at a fraction of the cost Western labs require. They operated under a hard physical ceiling. Due to export restrictions, they couldn't buy the latest hardware and were forced to build their model on a cluster of older, weaker 8800 chips. They solved layer 4 by optimizing architecture. Using mixture of experts, only a tiny slice of the neural network activates per question. Combined with MLA attention, the model focuses on data using significantly less raw compute than standard Western models. By redesigning how the model processes information, DeepSeek reduced the demand for processing power before the request ever reached the hardware. DeepSeek then moved down to layers 2 and 3, the chips and the infrastructure. They targeted the most expensive bottleneck in AI, high-speed GPU memory. Standard AI architecture requires hoarding specialized high-bandwidth memory directly on the graphics processor. This specific hardware is expensive, difficult to manufacture, and currently in short supply. Their technique, called engram, moves the model's temporary working memory off the specialized GPU chips and onto standard, inexpensive system RAM instead. By offloading memory tasks to cheap RAM, DeepSeek achieves frontier performance with significantly less high-end memory. This efficiency makes the power draw per token plummet. They solve the energy problem with better engineering, not more watts. DeepSeek has used software to route around the physical supply chain, showing the hardware stack can be optimized far more than previously believed. This drop in cost eventually hits the top of the stack, layer 5, the applications. DeepSeek released their model weights openly and set their inference costs at roughly $3 per million output tokens. At those prices, the application layer begins to commoditize. Building a frontier-class AI product is no longer a luxury reserved for companies that can afford to own their own multi-billion-dollar data centers. For the giants of the industry, this is a systemic risk. If the application layer becomes a commodity before they can monetize it, they may never see a return on their massive infrastructure investments. DeepSeek proves that the scaling assumptions used to justify the Western AI market are out of sync with what efficient software can now achieve. Moving the technological frontier does not require a trillion-dollar commitment to hardware, when smarter architecture can do the same job for less. The hardware shortage is a symptom of an industry still playing the old game of brute force spending. The moment the West acknowledges that resourcefulness can replace raw capital, the current AI hardware rally will face a much leaner reality.